One quick note before starting. This is a post-presentation recording made after the live presentation in Malaysia. Okay, so the main thing I want to show with this presentation is not only a set of results. To be honest, it is mostly the journey I took from my earlier CopyCat work into these newer open-weight image edit models. The image here is just the entry point. The important thing is the question behind it. Last year, I was working with CNNs in CopyCat using references to recover chroma and sometimes spatial detail. Now the question is different. If we no longer have paired ground truth, can these broader models still be constrained enough to do something useful for faded film color recovery? So this talk is about that path. What worked, what failed, what surprised me, and where I think the credible boundary is right now. Before I go into the examples, I want to point to the companion page. Some of the images and motion examples in this talk are too small to judge properly inside the slide recording. So if you want to inspect the source frames, the raw inferences, the final composites, or the motion examples in more detail, the companion page is the better place to do that. For the video, I will still walk through the logic, but the full-size files are there for closer inspection. The starting point is CopyCat. In CopyCat, the idea was more classical. You train locally, you use a specific reference, and you recover what that reference can support. The moving example on this slide is a reminder of that earlier route. Reference-guided recovery, with a much tighter relationship between the source and the training material. But with many faded films, we do not have that luxury. We do not always have a DVD, a telescene, another print, or a clean color reference. So the new question became, can a broader open-weight model recover missing chroma under archival constraints? From there, the work split into two main paths. One path is the unbalanced raw route, where we take the scan more or less as is. The other path is the balanced, deflickered route, where we stabilize the source first. And again, the goal is not attractive colorization, the goal is defensible recovery. Before going too far, I need to make this distinction. The comparison on the slide is important because correction and recovery are not the same thing. Sometimes correction is enough. If the color information is still there, even if it is damaged, then grading and balancing can recover a lot, but sometimes the chroma record is partly gone or effectively gone. At that point, correction is not enough. That is where recovery begins. And that is important because this is not a normal grading exercise and it is not stylized recolorization. The idea is that the original film frame remains the anchor. The source keeps the geometry, the grain, the edges, and the identity of the frame. What we are trying to estimate is the missing chroma information and then review that result as a restoration product, not as a synthetic image. One reason I moved in this direction is that I wanted to go beyond training one small model for one title. The workflow image here is not meant to be read node by node. What matters is that the process became repeatable. The practical stack was mainly Qwen Image Edit 2511 and later one VACE, all orchestrated through Comfy UI. But this is not only a model story. Automation became very important. Codecs helped me repeat tests, organize comparisons, keep experiment records, and basically make the process less anecdotal. Because to be honest, if you are just running one inference and saying, this looks nice, that does not tell you very much. The useful part is when you can repeat the test, compare the routes, and document why one result is better or worse than another one. One of the biggest practical discoveries was that there was not one source condition. The visual here is meant to show that the raw source and the balanced source are not just two looks. They create two different problems for the model. In the unbalanced raw route, the model sees the scan more or less as is. No balancing, no white point correction, and no deflicker before inference. That route became useful as a generic still image benchmark because it shows what the model can do with the difficult source directly. In the balanced deflickered route, the source is stabilized first. That may sound like a small difference, but it changes the whole problem. The model starts from a more stable condition, so frame-by-frame inference becomes easier to compare. So from that point on, the first question was always, what kind of source problem am I actually looking at? This is where the project failed very clearly at the beginning. The slide shows why the reference is dangerous when it carries too much meaning. In CopyCat, if you have paired ground truth, the reference has a very specific job. But in this new workflow, I first tried references that carried too much meaning, human references, leader-lady style references, things like that, and the result was bad because the reference was not only guiding color, it was donating semantics, it was donating identity, scene logic, and subject information. So then I realized that a neutral color chart was much safer. It can guide chroma without giving the model a foreign person to copy from. But even then, you still have to be careful because contamination can still happen. So this slide is really about the boundary between useful guidance and semantic takeover. This is where the idea of semantics became much more important. The image is not just an illustration. It is a reminder that the model is making a reading of the frame. It is not that semantics was never part of the conversation, but at this point, it became unavoidable. These models do not only predict pixels, they infer what they think the image contains. Sometimes that looks like understanding, but it is not the same as a human operator understanding a shot, a scene, or even a single frame. And in restoration, that difference matters a lot. Because if the model misreads the frame, it can start inventing people, materials, objects, or scene logic that are not actually there. So the issue is not only wrong color, the issue is a wrong reading of the image. That is why semantic ownership became one of the main constraints of the workflow. Once those early failures were clear, the question became, how do we make the product defensible? This lineage board is the contract of the workflow. Source, structural control, raw inference, and final composite. The source has to own the geometry, the edges, the grain, and the frame identity. The model is not allowed to become the owner of the image. This is where hard-canny became useful, because it gave the model a stronger structural anchor. We also had to understand the path that Qwen was taking, how it downscaled the image to accepted resolutions, how inference happened there, and how to invert that path back to the source geometry. Once we solved that alignment problem, the product became simple in principle. Original source luma plus generated or propagated chroma. And that is why the final review happens on the recomposited result, not only on the raw inference. This is the part where the project became genuinely useful. The contact sheet matters because it shows range. This is not one lucky image repeated many times. At the beginning, frame-by-frame recovery was too unstable. It depended too much on lucky cases. But once the prompt logic improved, once the references stopped embedding semantics, and once the geometry control was working, the still route started to generalize. We also did a lot of prompt searching. Basically, we tried to find prompts that worked not only for one image, but for many different kinds of faded material. So the claim here is not that one image worked. The claim is that the route now works across different scene classes, faces, crowds, daylight exteriors, classrooms, gardens, waterfronts, and other material. That is the first part of the project that I consider already practically useful. After the still route, the obvious question was, can these lessons survive over time? This moving example was the first temporal result that looked genuinely plausible across contiguous frames. What helped here was not only color guidance, we also needed semantic anchoring and descriptor logic. The model needed to stay inside one coherent interpretation of the shot. But again, the limitation is important. This was a favorable shot. It is a woman sitting in one location with relatively low motion. So it is not the hardest possible test. Also, if you look at the raw inference by itself, it is less trustworthy than the final composite. When you combine it back with the original Luma, it looks much better. But in isolation, you can see that some information has been lost or hallucinated. So this was a real success, but it was a bounded success. The cleaner bounded success is shot 0006. The video on this slide is important because it shows that the result is not only a still frame trick. Here the idea was to use a same shot recovered keyframe together with hard canny and let one VACE act as a temporal chroma donor. This worked better than the earlier interior woman example because it was less dependent on such a forgiving visual situation. For me, this is one of the strongest proofs that temporal recovery is possible for favorable low-motion shot classes. But again, I do not want to oversell it. It does not solve hard motion, it does not solve identity drift in general, and it does not mean video models are ready for restoration-grade temporal consistency in every case. It means there is a real path, but the path is still narrow. Here, I need to be very direct. The moving failure example is doing a specific job. It shows that the problem is not one ugly frame. The problem is drift over time. The hard failure is not isolated colorization. The hard failure is interpretation drift across contiguous frames. If you look frame by frame, you may get results that seem acceptable. But when you play them as a video, the model is often making different decisions from frame to frame. That is because the unbalanced source still carries flicker, instability, and small changes that push the model toward different interpretations. And current video edit models are not good enough for this restoration problem. They may work well for text to video or image to video, but image to video editing under archival constraints is a different thing. The models are still starved of spatial and temporal information. So smoothing or post filters can make diagnostics easier, but they do not solve the underlying problem. As of now, there are only 2 confirmed archive restoration quality temporal successes in this route. After the raw temporal failures, I move back toward the balanced route. The example here shows the logic of the context board. It is trying to give later frames memory of earlier color decisions. That may sound like a retreat, but to be honest, it made sense. This is closer to how I worked with CopyCat. In CopyCat, I always wanted the image balanced before training, because that makes the learning problem cleaner. With these models, the prompt is a little more complicated because you are showing the model an image that already looks balanced but still has missing color information. Even a human who is not trained in film restoration may not understand why color is missing when the image still appears to have color. But once that prompt and reference logic works, the balance route becomes much more stable. Then, context boards became important. The idea is simple. You create recovered keyframes and then use those keyframes as context, so later frames can inherit earlier color decisions. That works to a degree. But when the shot becomes longer than the model's useful context, it drifts into a new interpretation. So the balance route improves the starting point, but it still does not eliminate temporal instability over distance. The atlas idea came from a reasonable intuition. The visual here is useful because it shows the appeal of the atlas. Many references at once, more context, more possible guidance. If one reference helps, maybe many references help more. But in practice, the atlas often becomes its own semantic object. We understand what an atlas is supposed to mean. We understand that it is a collection of references for the same problem. The model does not necessarily understand that. So sometimes the atlas gives beautiful color, and sometimes it gives useful direction. But as a restoration method, it is still inconsistent. The lesson is that more context only helps if the model can interpret that context correctly. And that is still one of the big limitations. This is one of the directions that interest me the most right now. In this comparison, the important thing is not that tiling is perfect, it is that the raw inference often holds more detail. The question was, what happens if the model has more spatial information? That is where tiling becomes interesting. Tiling is complicated for image-to-image work because it can create seams and local mismatches. But the results are still important. In the raw inference, you can often see more detail than in the ordinary single-frame route. Sometimes you even start to see grain come back. That suggests that these models may be starved more by spatial context than by color alone. So one possible future path is that stronger spatial context may eventually become the bridge toward better temporal context as well. If the model can work at a higher spatial level, maybe later it can also work with better temporal consistency. So where does all of this leave us? The final visual is there to bring the examples back to the claim. This is constrained, imperfect, but real. I think the honest claim is strong, even if it is not magical. Still, image chroma recovery is already useful across varied faded film material. Temporal recovery is real, but it is bounded to favorable shot classes. The balanced path, context boards, tiling, and larger spatial context are the most promising directions. And ethically, if surviving channel information still exists, then we should use it. To be honest, going straight from black and white to color may sometimes look better, but if the scan still has partial color information in the remaining channels, then restoration has a reason to respect that information. So I am not here to say that this solves everything. I am saying that there is a constrained path here. It is imperfect, it is unfinished, but it is real. Thank you for listening, and thank you for giving this work your time and attention. I also want to point again to the companion page for full-size examples. A lot of these images and videos are too small to judge properly in a slide recording. And that matters, because the argument depends on inspection. You need to look closely at the source, the raw inference, and the final composite. I will also keep adding these experiments and documentation to the repo, including the limits and the failures, because that is the only way this becomes useful for other people. Thank you.